In question number 2, they're giving us another sequence, and this guy's claiming that the recursive equation in number 1 could match that sequence as well. Now it's worth noting that does not look anything like the sequence that we had in number 1. We had 10, 7, 4, 1, and this is 12, 9, 6, 3, 0. So it doesn't look like it's the same sequence, and yet this guy's claiming the equation works for this one too. Let's find out. Let's see. Remember what we did with the little table, and we tested the table with the equation? Let's see if he's right. Let's see if it actually passes a quick test. So n and t of n. Dan's sequence starts with a first term of 12, a second term of 9, a third term of 6, a fourth term of 3, and a fifth term of 0. So I'll just write down his numbers. And let's test his equation. Remember, he's claiming that the same equation, t of n plus 1 equals t of n minus 3, works for his numbers. So let's see if that's true. I'll pick the same second term, although I am noticing the second term of Dan's sequence is 9. I did it the first time with a 7. Well, let's see if it works. T of n, that was 2, plus 1, equals t of n, that was 2 again, minus 3. T of 2 plus 1 is really 2 plus 1 is 3. So t of 2 minus 3. This is looking exactly like the work that I did in the previous question, so I don't really see what he's getting at here. How could this possibly make sense with his numbers? T of 3, I'm looking at the table, t of 3, third term, that's 6, so I'll plug in 6, equals t of 2, that's 9, minus 3. But then I look at this and go, oh, wait a minute, hold on. That's true. 6 is equal to 9 minus 3. That totally works. That totally makes sense. And that doesn't seem right. Like, we did the exact same work in number 1 and in number 2, and we're getting totally different numbers, but both of them are correct. Like, we know that's not really a thing with math problems. I mean, heck, some people, the only reason why they can tolerate math is that at least there's always one right answer. They know for sure, like, okay, yes, there's one right answer. I don't have to debate. I don't have to think about both sides. I can just know that my answer is right. And yet it seems like here, you could have 2 totally different numbers to plug in and 2 totally different end results, and yet both of them are correct. That doesn't make too much sense, does it? So in letter A, we can at least acknowledge, yes, he is correct. And if you had to explain, I would simply say something about what you plugged in. Like, because I plugged in the second term and the equation worked. You could use an explanation just like that. So in letter B, it says, how is it possible that the same equation could generate 2 different sequences? And it's possible because technically, all the equation is telling you to do is subtract 3. What it's not telling you is where to start subtracting from. So in number 1, they gave you the 10 as kind of a kicker, and you could see that the subtracting 3 happened based off of that 10. In number 2, they gave you the 12, and again, based the whole pattern off of that. So depending on where the equation wants you to start, you will get different numbers, even though the equation itself looks basically the same. So that's how it's possible, is because the equation itself doesn't tell you where to start. It's kind of a loophole. It just tells you to subtract 3, but it doesn't tell you where to begin. And there's an interesting thought exercise that you can do here, because you might realize why it's so important to know where to start. Now, I'll get to that in a second, but let's just quickly knock out letter C. It says write another sequence that could also be generated by the recursive equation. Remember, all of this recursive equation stuff, everything that you saw here, is just saying to get to the next term, take the current term and subtract 3. So you could make up any number that you want to and use that as your starting point. For example, let's say you really love the number 100. You could use 100 as your starting point and then subtract 3, subtract 3, subtract 3, and so on. You could write any sequence that you want to. So pick your favorite number, pick your birth date, pick the last 2 digits of some important number to you, whatever. Anything is fine. And then subtract 3. And you'll prove to yourself that that equation will always work. You can make the table and everything. The equation will always work, no matter which number you pick, which is kind of trippy. So in letter D, where it says what additional information besides the recursive equation is needed to ensure that we have a recursive equation that matches an answer, not this free-for-all or any answer could work ever, is you have to specify the starting term. You can't just say an equation that says -3. It has to be more specific. And I'll show you why. Here's a quick thought exercise. What if I showed you that equation and said, start thinking about numbers that would make that equation work? This equation translates to say, okay, to get to any term, whoops, I'm writing the wrong thing. To get to any next term, take your current term and add 5. So picture that sequence. Picture any number you want to, and then add 5 to it, and then add 5 to that, and then add 5 to that, and then add 5 to that, and go on as many numbers as you want. You don't have to go very far. I thought of a sequence as well. I've already written it on my paper, and I'm going to just kind of roll the dice here. I'm going to bet that there are very few people watching this video, if any at all, who picked the exact same sequence as me. Here's the one I picked. Were those the numbers you had? Because you have to admit, 63 is a pretty random place to start, and those numbers may not have matched your numbers. And that's not because you were wrong and I was right. It's because, technically, I didn't tell you where to start. So let's try it again. This time, I'm going to tell you the exact same equation is true, but I'm going to give you a kickstart. T of 0 equals 4. Take a second, or maybe even pause the video. Can you write, let's say, the first 5 terms of that sequence? If I gave you a starting value and then said go from there, could you write the rest of the terms? Take a few seconds to think about it, and then ask yourself, did it match what I have? If it did match this time, and you're like, oh, I got the exact same answer she did, that's why. It's because, technically, I had to tell you where to start to guarantee we were all on the same page. If we all started in different places, we would all be going nuts. So that's the kicker. You have to know where to start, and you have to have an equation. Just one or the other doesn't give you enough info. By the time you get to question number 3, we're going to talk about and make sure that we know how to write that crucial 2-part definition.